Hello and welcome to Experts on Demand Standing Study Considerations for Bilateral Users. Bilateral lower limb amputees are a unique population that requires special attention during the rehabilitation process. This webinar will address these additional challenges and showcase componentry suitable in the prescription of lower limb prostheses for this population. After completing this training, you will be able to list 2 possible causes of amputation and likelihood of bilateral amputation secondary to diabetes, describe the 3 steps in the rehabilitation process specific to bilateral users, state 2 reasons for using the short leg graduated protocol, describe 3 of the unique features of Ottobock microprocessor knees that support the bilateral population, name 2 programming parameters for bilateral users in Ottobock microprocessor knees, and finally, to receive 1.25 ABC CEUs, please complete the quiz for this course. Enjoy!
Welcome everyone to our Experts on Demand session today. This course is titled Standing Study Considerations for Bilateral Users. So we will be discussing bilateral users, specific considerations for this patient population, and really how you as a prosthetist can benefit and support your end users to have an optimal patient outcome. Working with bilateral users is such a humbling and inspiring process, and I've had the privilege to see many bilateral users thrive with the use of Ottobock microprocessor knees, including my colleague Erin Holm. Our goals today are to discuss the bilateral rehabilitation process, aspects of physical therapy, the step-by-step graduated approach to walking, and the benefits of MPKs with specific settings designed for the bilateral population. The specific programming parameters will be discussed, as well as special considerations when working with these end users. So to begin, I'd like to introduce Erin and let him tell you a little bit about himself, his story, and the process in him becoming a full-time bilateral above knee wearer of microprocessor knees, with full-length microprocessor knees. Erin is our manager of consumer engagement, and here's just a short video to show you who Erin is and him walking with a friend of his, and then he will introduce himself at the end of this video. Thank you so much. Erin, I'll pass it to you.
All right. Thank you, Ariel. I think that's the end. I'm getting a pretty slow response on the video, so I'll just start chatting a little bit. But as Ariel mentioned, my name is Erin Holm, and I am the manager of consumer engagement for Ottobock North America. And my personal bilateral standing steady story starts back in January 2nd of 2007. At the time, I was a regional manager for an information technology and engineering consulting firm working downtown Minneapolis. On January 2nd, after returning to work from the holidays, our office received a phone call from one of my administrative assistants stating that she was stuck on the side of the highway. She had a flat tire, and she was waiting for a tow truck to come and get her. The tow truck was summoned to an emergency. She had called back in, and I decided at that point to go pick her up. In the process of picking her up, I decided to change the tire while I was out there and get her in her car to safety. And in the process of putting the flat tire into the trunk, an individual traveling on the highway at 55 miles an hour struck me from behind, pinning me between 2 vehicles at 55 miles an hour. As practitioners, you've heard a lot of stories, probably some very similar to this. But my life obviously changed in an instant. One leg was lost at the scene. The other was removed via surgery at the same level a couple days later. So as a result of that injury, I'm a bilateral transfemoral amputee, actually a knee dysartic as the result of trauma. Thrown into a world of uncertainties at that time, like a lot of trauma victims are. In 2007, the internet wasn't a terrific source of a terrific resource yet. Not that I'm saying it's a terrific resource today, but it certainly has improved. There wasn't a lot of reliable, validated information out there regarding limb loss, particularly my level of loss. the high spectrum of a bilateral above knee amputee, and the available products, componentry, the passionate people that make up this industry. So we were kind of in the dark for a while, and we formed teams, and the recovery teams went into full discovery mode, try to figure out the components of recovery for a bilateral above the knee amputee. And as the bullets state here are the components that we decided that we would focus on for my recovery to get me back to the desired lifestyle that I wanted, or the desired lifestyle. Obviously, a big part of that was the prosthetics and the practitioners who would fit my prosthetics. I identified the sea legs early on. There weren't a lot of opportunities or a lot of components at that time, selections for me, and I identified the sea legs as the components that were going to help me get back to where I wanted to go, or get me to where I wanted to go. And then physical therapy, and I have physical therapy A and then really physical therapy B. We focused on pre-prosthetics. Learned early on that my core strength was going to be incredibly important, upper body strength, as I would depend on my upper body more than I ever had in my entire life. So I would maximize my time spent in physical therapy and do as much as I could to prepare for the fitting. TheraBands were the best thing for me. I could use those in the hospital right away. Just the TheraBands you're probably familiar with. Sit-ups, push-ups eventually. Independence, mentally physical. Is MT a thing? Like PT is a thing? I think it is. But we leased or acquired a wheelchair accessible van with hand controls, and I could get around in the winter, attending my kids' hockey practices, games, daughter's competitive dance and figure skating, malls, Costco runs, anything to get out of the house. I had a manual wheelchair that helped me build my upper body strength and endurance, and certainly provided for a resource for cardio as well. So we were getting very aggressive, getting that body ready and filling up the space, filling up that downtime that exists between trauma during the recovery mode before we can even consider prosthetics. My initial prosthetic fitting was in March of 2007, so just a few months after. I showed up, and the initial check socket was attached to the stubbies. Practitioner and his team, the intentions, I think, were to keep me on these stubbies for maybe a few days, a couple weeks, but I, at that time, was a bit stubborn. I wasn't having it. I was ready to get up and get walking. My daughter had been kind of bragging it up that she was taller than me, and the gauntlet was thrown, so I was going to be pretty aggressive. The components that were given to me were the sea leg 2s, the gray model, if you recall. I was super fired up to put these on and felt that I was prepared to get up and get going. I was in great shape, and I had been athletic growing up, so I felt I was just going to get up and get going. The alignment and fit was dialed in. The check sockets felt great, and I was ready to go. It was a kind of a shock to me initially, trying to take that first step, if you recall, toe load to initiate the swing of the sea leg 2. And I couldn't get that magic pop or rollover to happen. We spent several hours and several sessions just trying to get me to be able to trigger that knee. And once I ultimately triggered it, having my brain switch gears from my right leg to the left leg, and my practitioner and his team were just phenomenal and concerned, I think, easily. It was, the microprocessor was a relatively new product at that time, and we were checking battery and we were checking program, and they had everything dialed in. It definitely was user error. So it took a lot of time to initiate that trigger, getting the toe load figured out and taking that step, and then being able to trigger the other one and doing that time after time. So it took a little while. I took an aggressive approach between the practitioner's office and my physical therapist. We found a physical therapist that was confident in the sea leg. She had attended a sea leg session similar to this one at the time, so she was knowledgeable about what that product was capable of doing, and would maximize those sessions with her. I initially started walking in Lofstrand crutches. Outside of the parallel bars, I used the Lofstrand crutches for about, I don't know, 4 or 5 weeks, something like that. And then I graduated to a cane, which I used for about a week. And then in about early June of 2007, I began walking unassisted and have been walking unassisted ever since. So I learned to walk and gained my confidence on the sea legs, which I wore for the first 6 years post-injury. And with that, I'll turn it over to Ariel.
All right. Thank you so much, Aaron, for that great introduction. So I wanted to start with just some limb loss statistics, and just as a kind of general overview, there are nearly 2 million people living with limb loss in the United States. And among those, the main causes are vascular disease, diabetes, and peripheral arterial disease. About 45% is from trauma, motorcycle accidents, pedestrian, train, and car accidents, and burns. Cancer, about less than 2%, and we still see congenital limb deficiency, about 1,500 to 4,500 children affected annually. Nearly half of those individuals who have an amputation due to vascular disease, which was 54%, will die within 5 years. And this is higher than the 5-year mortality rates for breast cancer, colon cancer, and prostate cancer. Number 4 here is probably our most significant, that of persons with diabetes who have a lower extremity amputation, up to 55% will require amputation of the second leg within 2 to 3 years. So if you are seeing, below knee and above knee, or someone starts with a below knee, then goes to above knee, and then maybe a secondary scenario that way, that is pretty common and typically from diabetes. Statistics have shown and studies have shown that mobility by ambulation with prostheses profoundly improves the quality of life as compared with a wheelchair existence. So this is something, really important as we look at the bilateral population. I was speaking with a practitioner yesterday who said, he was seeing unilateral users walk in or come in a wheelchair and walk out with a prosthesis, but bilateral users come in a wheelchair and leave in a wheelchair. And it was really important to, determine, how do we fix this? How do we help bilateral users, more specifically maybe bilateral above knee, but how do we help them return their independence with prostheses? So these are various prosthetic components that can be considered for bilateral users. Of course, depends on the level. We have below knee, above knee, hip disarticulation, maybe some combination. In this first photo on the upper left, this is a congenital user. He was born without both of his legs below the knee and missing his left arm above the elbow. He is currently wearing Taleo feet, which are Ottobock carbon fiber feet with the super flexible inner sockets, custom liners, and passive suction with sleeve suspension. He also has a running setup on the bottom left with completely different sockets for this setup, and these are challenger feet. So he's running about a 5K, and he was training for a half marathon, and he uses a completely different setup. So this might be possible and may not be possible for everyone, but pretty important, to be able to consider what the user needs in the whole spectrum. Yes, walking, maybe some athletics, maybe they just want to get in a kayak, maybe they want to go play hockey, maybe they want to just sit on the floor with their kids. So thinking of the big picture and what components can help them meet their ultimate goals. Vacuum suspension is really a great suspension and great limb environment, and can help with wound healing, increase proprioception, all of those different things. So as you're thinking about kind of building the prosthesis, what components are available, what's out there, you see in the upper kind of middle section some historical photos. So we've really come a long way with microprocessor knee technology and really seen that advancement, from wheelchairs to walking with the new technology that's available. There are also incredible sporting components. The Paralympics are in full force in Tokyo, and that's really exciting to be able to see some of these components coming about and being able to be utilized by this population. So jogging, sprinting, court sports, and those types of things. So as we look at building the prosthesis, considering what components fit that individual, and I think it's a really individually based perspective. Everyone's unique, and we have to consider all of those elements as discussed. Starting with the socket and considering proprioception and muscular control, total surface weight bearing, trim lines for sure. What do they want to do? Do they need to get on a bicycle for some exercise? Do they sit or in a tight office space? What is their environment? Double wall designs and various activities are all things to consider when evaluating the socket. Of course, socket fit is going to be really key in their success with having that good intimate fit. For suspension, looking at vacuum and suction options, maybe a liner with a lanyard, if that is something that is being considered. Endoskeletal design really helps with being able to change out components. Some people can use, one socket setup for multiple things with quick change adapters. The gentleman I was congenital user did used to have quick change adapters for his running setup and change out his feet until he was able to get a new socket set made. So sometimes that's a great option as well. We'll talk a little bit throughout this presentation about different adapters, the use of a rotator for easy donning of clothing, shoes, dressing, quick change for changing out feet if that's something that's desirable. And we'll talk about maybe the benefits of torsion or advantages and disadvantages that might be there as well. When we look at the above-knee transfemoral amputation or end user, then we're looking at mechanical versus microprocessor knees, and we'll talk about that throughout this as well. And then the foot, really focusing on, what does a bilateral really need? K-level may come into play a little bit, may or may not. Sometimes there's some variables there with K-level and bilateral users, but for the K2 population, the Terion would be a good option. It gives a good base, and the Triton family of feet. We don't want something that's too flexible, too much movement. Microprocessor ankles are coming into play more, and sometimes the bilateral user can benefit from those. But there are also times where it might just be too much movement. So we'll discuss that a little bit as well. We talked about the rehab process and physical therapy, and Aaron mentioned, physical therapy A and physical therapy B, kind of that initial physical therapy. If they can get it right away, that's absolutely ideal. Beginning with mobility, working on range of motion and daily stretching, and that's probably going to be something that they continue to do. Most able-bodied people have some sort of regimen on a regular basis that they do some stretching, maybe they do some yoga, but that's all very important in making sure that we don't develop contractures for the bilateral users of the knee or of the hip. Maintaining strength, increasing mobility and blood flow will just keep them being able to be fully functional in their prosthetic devices. So really focusing for the below knee user on strengthening the quads, hamstrings, overall leg strength to build that foundation for socket fit and function. And that can also really help as we look at componentry. Which componentry, if the user has more voluntary control, maybe they can use different componentry versus if they need more inherent stability in the prosthesis. For the bilateral transfemoral user, similar to unilateral, however, the requirement for physical therapy, daily conditioning, stretching, and weight control is significantly magnified. They'll really need to focus and commit to that process of rehabilitation. A regular stretching routine, maintaining their physical health and weight control for sure. Confidence and motivation are certainly key, and having a good support network has been shown to really help people advance and progress in their rehabilitation. So this is a chart from a study that Kevin Carroll and Randy Richardson did, looking at, and Randy was the one who mentioned to me about, seeing people coming from in bilateral above knee users specifically coming in wheelchairs, and then, sometimes not even being able to get a prosthesis. And a lot of it was, how do we trial and error? How do we figure out these, what they're missing, what they need to be successful and be independent? And independence may be defined differently for different people. If you never used a wheelchair before your amputation, then, maybe your goal is to never use a wheelchair after. That may not always be the case. That may still be something they'll need supportive and assistive devices depending on where the user is and what their goals are. But really, starting with this process and working through the 4 steps has shown to be the most successful with the best outcomes that they have seen. So building confidence with peer-to-peer support, having that, being willing to participate in that process of physical therapy and conditioning, and having family and friends supportive is extremely important as well. Walking on short legs, often referred to as stubbies, is something that is really helpful for generating that initial stability and also working with safe ambulation around the house. Some people may use stubbies, permanently. They call them stubbies for life, or almost think of them as like your slippers when you get up and do the things you need to do around your home. Graduated increases in height, and this will come later as the user shows that they can ambulate very well on their stubbies. There are times that, people don't get stubbies at all, but sometimes, going back to that can also be helpful so that they gain that core stability and strength, and then ultimately walking on full-length legs. So that step-by-step approach, as I talked about, starting with the stubbies really helps because it requires less energy expenditure. It allows the user to walk a little bit faster, at least initially, for burning calories and things like that. They can get around quicker. They can navigate their home and their environment. It really encourages balance as well as hip and residual limb strength. And there's a reduced risk of falling because they can learn from a lower center of mass how to fall and get up. So a lot of times, if you may have seen or heard of the bilateral boot camps, they'll work on just falling and rolling and getting back up off of the ground. Stubbies have been used, as I mentioned, for some people that may not graduate to full-length legs. They may just use stubbies if they're in-home walkers or mainly just getting around their environment. It's going to be something that is really a team approach. So having the doctor, the physical therapy, and a great support group on board can be extremely helpful as well. This was a study that looked at complex. Yep.
Ariel, we've got a question. If you can just go back to your previous slide there for us. A question has just popped in. What assistive device would you recommend when you are starting off with bilateral stubbies? Would it be a short walker, a 4-point cane, or what would you recommend there?
It kind of depends on what else is going on, what other elements. If they try and just keep them as low as possible to the ground, so they may not need anything. A short walker can be possible. That has been used before, and then they can progress to a cane if they still need something. Usually, if they can start even with lower parallel bars, if they just need something to kind of balance and work on that balance in PT, they'll start with just the balance aspect to begin with, and hopefully work on that balance piece before they're really moving forward too much. Great question. All right. So as that leads into, using it as a training tool, stubbies can almost be like that element that helps them, since they're so low to the ground, can be that training tool of learning that balance piece. If they need something to hold on to, then they can do it with a low, counter or table, something that may be modified in their house to help them along the way, or that shorter, almost like a kid's walker to some degree, or something that they would use with like an RGO or something of that nature that might be used. I've seen those before as well. Stubbies can also be for a permanent option for the user who ambulates within their home, as I mentioned before, and maybe the elderly user where safety and energy efficiency are the most important. Some people still use their stubbies, for certain ADLs. They'll design stubbies for specific activities. If they do things that they just want to be lower to the ground, they might just sit on the floor and play with their children with their stubbies and not have their longer legs on at those times, or get up in the morning and make their coffee and go about their day and do the things that they need to do before they put on their longer legs to go out in the environment. So it just really depends on the individual and their needs. So these are a couple of different pictures of different types of stubbies. There are some that are off the shelf. So you can get off-the-shelf ones, but typically a lot of prosthetists will make their own and customize them, again, to what the user needs. Do they need them to be a little bit bigger or a little bit smaller? Sometimes the off-the-shelf ones can be maybe bigger than they need, or some of them have motion. So the College Park design on the upper left, those are multi-axial. So they will allow the user to really use the muscles needed for walking and help provide that range of motion throughout the gait cycle. So that can be really beneficial for certain users. They can also help, stubbies in general can help get contractures worked out so that they can start to be a little bit more upright and stretch their hips. Preloading the feet is really important for balance. As we talk about foot selection, having that stable foot and that stable base is important. So this can help, them stand a little bit more upright. Bilateral users kind of tend to stand extended and slightly adducted to create that socket stability with their musculature. And so sometimes you'll see, people walking around where it seems like they're almost a little bit extended if they've worked out their contractures, and that can be beneficial to get them a little bit more upright. Alignment, of course, is always the critical success factor in fitting any prosthesis, but the bilateral user, they have to rely on the alignment that you've provided. They don't have a sound side. They can't just balance on, their sound side, and they really can't cheat. So alignment is extremely critical for their optimal walking. As we progress from stubbies, there are different theories of thought. It really depends kind of on where you are in the country. So there, maybe some physicians have their opinions, but from what I've heard mostly for people I work with a lot of bilateral users, is that they want them to be in stubbies until they're performing all their activities fairly independently. So they should be able to go about the things they want to do during their day in their stubbies, whether that is, just going to the grocery store or going, playing on rocks and walking in a small stream. I mean, it can vary drastically to what the user wants to do. Play with their kids in the park, take them to the playground before they graduate to even taller legs. But we can start with incremental increases in height. As Aaron mentioned, he didn't want to be shorter than his daughter, so they started working their way up quicker. You can also start with low-profile feet and then maybe go to higher-profile feet to add some height. You can add locking knees so the user can sit, so that they could sit in a typical chair is about 18 inches high. So that's ideal, really, to be able to fit into a chair. And then really determining that overall goal height and setting realistic expectations. So family and peer support add a great benefit. The shorter that the user is, the closer to the ground they are, and typically they will find benefit in being a little bit shorter than they were before. But that's, to each individual's discussion that they have to have with themselves, with their prosthetist. And, a lot of times people will get too tall and then, realize that they were more successful when they were a little bit shorter. So during that transition from stubbies to MPKs, consider that aimed definitive height for the user. You can start off, as I mentioned, with the different feet, and then a rotation adapter can also be very nice. Maybe they only want it on one side, If they have the room for it, they don't necessarily need it. It's, everything, you think about componentry, everything adds some element of weight and more moving parts. The one thing about the rotator, is it's great for donning clothing, putting on shoes, sitting on the floor, getting into tight spaces, maybe in and out of vehicles, but they can manage to do that without them as well. There are plenty of bilateral users that don't use one successfully, but it's definitely an option and worth considering. All right, this is a video of Aaron, and he is walking out of his house off of a door ledge there, sitting down and standing up. There are a lot of new features within some of our microprocessor knees that have some different support for sitting down or for standing up. Some training tips and things are to keep maybe a wider stance, keep that center of mass over the bending point of the knee, use armchairs when possible. Standing up really depends on kind of where they're at in the process, but they may need to use more of their upper body initially, tightening their core, using their core, maybe an additional mode for practice in ratcheting up and prevent falling back into the chair. And again, as I mentioned, core strength. With the Kenevo microprocessor knee, we'll talk about some benefits with standing as well. Getting off the floor is also something. A lot of bilateral above knee amputees will don their prostheses on the floor. They find that this is just easier. As you see here, she's using a rotator so she can kind of cross over. Again, a nice option, not necessarily mandatory, but can help a lot. And then they'll roll over, maybe extend one leg, extend the other in almost like a downward dog position from yoga, if you're familiar with that, and then stand up or walk up the legs. This can also be done, if you're not somewhere with bars, if you can get near maybe a wall or eventually, have enough strength to be able to get up without needing anything at all. But that can be a process to kind of progress through. So as we talk about microprocessor knees, again, in speaking with several clinicians that I know who fit a lot of bilaterals regularly, I've asked them, what mechanical knees do you use if they can't get a microprocessor knee? And it's surprisingly, many of them have said, it's been so long since I've fit a bilateral user without a microprocessor knee. But there are certainly some scenarios where that's not an option, and there are mechanical knees that we'll talk about as well. But evidence does show that there are benefits for microprocessor knees. An 80% reduction in falls. This is for unilateral as well, so not just specific to bilateral, but just in general compared to mechanical knees. 80% reduction in falls, reduced risk of falling, improved balance and confidence, 14 to 25% faster walking speed on level ground, 20% on uneven terrain, 30% faster slope descent, and improved quality of stair descent. So think about some mechanical knees and how you would even go downstairs with them, if it's even possible, if it's possible to even go down a ramp, or if they'd have to sidestep down a ramp. Improve performance in activities of community ambulation. So about 50% of K2 level users improved to a level K3 level, and improved indoor ADL performance. So some pretty significant justification for why an MPK can be beneficial over a mechanical knee. So looking at mechanical knees, what are some of the disadvantages? Sitting, sometimes you have to rock onto the toe to be able to sit with certain types of mechanical knees. A lot of them don't have a yielding resistance where they can just ride the knee down. So they're kind of just falling into a chair. Break knees may require that unweighting or unnatural movement pattern to release and sit. And then once the user has released the mechanical knees, if they don't offer any stance resistance, then they're just really falling back. And that's evident on ramps and stairs as well. So they may just be falling down the ramp quickly, having to go as fast as they can or into the stair. And that can be jarring to the rest of the body, thinking of that overall big picture. Often a handrail will be necessary to use their upper body to support that controlled fall, or the user might have to just modify, sit down, or sidestep down the slope, or avoid it altogether. And that's, can be unfortunate and difficult in our world in general. And level walking. So when I think of microprocessor knees, the biggest benefit is that stumble recovery, being able to catch yourself when you fall. Again, there's no sound side to rely on. So as I was just walking earlier today and tripped on a carpet walking out of a door, and I'm able to catch myself with my quads just reacting and able to prevent that fall. So that fall prevention and ultimate, ending up in the hospital again for some other reason is certainly not ideal. So these are a couple of videos of a user on mechanical knees. She has to figure out how to release them. In this case, she rocks onto her toes to release. Not quite an ideal scenario for sitting on a regular basis. And here she's in sea legs. These are some pretty old videos, but I thought they were still so relevant in comparing and showing that difference. She's able to really ride the knees down with that yielding resistance. Same thing when going down a ramp. Here on mechanical knees, if she tries, it's just going to pretty much buckle. So she's got to really take these little tiny steps, keep them extended, keep weight on the heels, go down. It's a pretty steep ramp, but go down really slow. With the microprocessor knees, she can go down a lot more naturally and a lot more smooth. She may also prefer with the mechanical knees to sidestep down or pick a different way. And then stairs, really with the microprocessor knees, you can see a huge benefit. With the mechanical knees, she wouldn't really be going down the stairs. So I'd like to invite Aaron back into our conversation here and talk about, how the microprocessor knees have benefited him. We talked about, sitting, support for sitting. With the Kenevo, we'll talk about some support for standing. So people that are maybe starting out in their rehab process and need that support standing so they don't just fall back into the chair. Navigating curbs, stairs, ramps, and specifically stumbles. So that the microprocessor knee really offers that stance resistance to ride the knees down to the chair, step off a curb, descend slopes, stairs, step over step, and provides that stumble recovery. So Aaron mentioned that he wore sea legs to begin with, and now he is wearing X3s. But Aaron, would you like to tell us a little bit about some of the scenarios that you found this to be of extreme benefit?
Yeah, absolutely. And I've become accustomed. I think all of these features have become second nature as you learn to trust the technology. And I think that's the biggest thing early on is you certainly can read the manual and understand or recognize what the knee is going to do in certain circumstances, but you have to learn that's really going to happen, and you have to learn to trust that. And I have learned to trust most of these situations or sitting, standing curbs. I think the stumble recovery feature, if I were to pick one of these, I don't know how often that kicks in, and I don't recognize it because of the intuitiveness of that feature. It happens quite often. I travel a lot, or I travel a lot for Ottobock, stutter stepping through airports, where everybody knows nobody pays attention at the airports, crowded areas, where you might have to stutter step through a crowd. Just Monday, we got some rain on Sunday, so I went out to put the pump on our swimming pool. And in the process of putting the pump on the swimming pool, the hose or the electrical cord, one of them wrapped around my right foot without me knowing it. So when I went to step forward, the knee obviously didn't come with me as much, so I caught the toe. It went into the resistance mode. I caught myself with the left side. My heart skipped a beat a little bit, and nothing. I just went on with my day. But now, if that was a fall, it would have been on some hard concrete next to a swimming pool. I would remember it probably for quite a while. But talking about this presentation, it came to mind that it happens all the time. And that, like I said, the intuitiveness of that feature alone saves a bilateral above knee amputee quite a bit. The intuitive stance, I don't think I use it as much as I could, but I do use it. I think about hockey games. Our kids play hockey, and I like to stand during the games down by the ice on the glass, and in between periods, I lean up against the glass or a wall and lock in my knees and take a little bit of the load off my lower back as it gets a little sore from standing for 30, 35 minutes a period in cold weather, etc. So I do use that. Additional modes, I don't use the app as much, but I've talked to a lot of people that absolutely love the app, as Ariel has listed here, driving without hand controls, being able to lock in that prosthetic knee. I use hand controls personally. I just think it's easier for me to react, and safer, I think, to react from gas to brake in certain situations. So.
Awesome. Thanks, Aaron. And we'll talk a little bit more about that intuitive stance feature that he was mentioning. There are programmable modes. The Kenevo now has an automatic bicycle mode that can be utilized and turned on or off. The C-Leg has 2 additional modes that can be programmed for the user, and the Genium and X3 have 5 additional modes. I think it's great to just put some modes in there and see if people will utilize them. They can be sport specific. We have a ton of different options for programming things within there, and then the user can see if they will utilize them or not. So as we've mentioned, MPKs deliver a huge benefit for the transfemoral amputee. Good alignment is critical. Starting in the parallel bars, starting with a physical therapist if that's possible, and really, getting to trust the knee and utilize it to its fullest. So getting that body posture. If you look at all these pictures, look at the alignment and take a look at what you see in some of these different photos and videos as I go through this with alignment. Really, alignment's done, fairly similarly to the unilateral user. They might want a little bit more stance stability, or have the ground reaction force more anterior to the knee potentially, but hip flexion contractures really have to be accommodated for step length, for being able to activate the prosthesis. All of these things for stability, absolutely essential. So we'll look at some of the different alignment tools that we have within some of the microprocessor knees as well. We still want to get stance flexion. If the user can use stance flexion and benefit from the stance flexion, then they can really gain the benefit and trust in the microprocessor knee. So measuring that contracture via the Thomas test is how we recommend to do it. Even if they're stretching it out, we may have to accommodate it at that point so that they can be the most successful, and then slowly back it off throughout. We do have some tools. This is a 3D laser posture. So if you ever have an opportunity to see one of these or get one in your office, or if you're fitting a bilateral user, you could request one from us, and we'd be happy to come show it to you, or we have loaner programs and things like that so that people can utilize them. So we may not see, this is kind of maybe what you typically see even for a unilateral, and we're trying to get more of an ideal situation. We may not quite get here for the bilateral user, but we can get pretty close. And we're looking at both the horizontal and the vertical component of the ground reaction force. So we're able to really see with an objective measure, not just a subjective measure, where the ground reaction force is in relation to the prosthesis. A little more safety than with unilaterals may be desired, and we aren't going to worry too much about the midfoot. It's not going to be our main focus. A lot of times I'll still tell people, do your alignment. This is just a tool. If you have access to it, great. The process would be to adjust both sides to enable a force trajectory as similar as possible, minimizing those horizontal forces, but we may not get them to both be 0 or both be quite equal. Knee stability is going to be our highest priority, and if we have a good alignment, then really it should just be small changes in plantar flexion or dorsiflexion once we have really dialed it in. So here, if you look at this alignment, you really see they had to actually change and move and bond and rebond this socket several times to be able to dial in this user. And it can take time and it can be challenging, but if you spend the time here, then they'll be the most successful they can be. With the Genium and X3, we have this alignment tool in the software. Again, it's a tool. It shows the overall ground reaction force, the horizontal component, and then the load as well on the prosthesis, and it's updating continuously. So you can come back to this after you've walked a little bit as well and kind of double check and see, where they're at. Sometimes you just do your alignment how you want to do it and then use it again as a tool. So you may not need to focus on it, too much and get too detailed, but you do want to use it as an option. You can use 2 laptops, which can be great. One connected to each knee is helpful, or you can have 2 data stations open if you have 2 of the 60x5 components and just toggle between those 2. One side will affect the other. So then if you can get 2 laser postures or one of the 3D laser postures, that can be really great too to see the effects that the other side might be having. And we will lock the knee joints in when we're looking at the alignment in this scenario so that we're making sure that everything is stable and that the knee is completely locked out, so taking out any other aspects. So this would be what we would see. This is an alignment optimization example in XSoft. And as I mentioned, ultimately we're typically looking to be all in the green, but you don't have to get really hung up on that. Again, it's a tool. Here we have a little more stability. The line is a little bit further in front of the knee than we may need for a unilateral user, but you also have to take into account, are they using stance flexion? Are they able to initiate swing easily? There's always that trade-off, right? Looking for that perfect balance between mobility and stability. As we talk about feet, we've talked a little bit about that standing stability. That's really essential for the bilateral user. So very flexible ankles can sometimes have a negative influence on that standing stability. And we don't want too much movement to distal. Otherwise, the feet will take over and the knee won't be able to do job to the optimal ability as well. So feet with more stable ankles can give that higher stability. And typically for the transfemoral user, the Triton family can be good. The Taleo family maybe for the transtibial user. And you can also look at foot category as well as a consideration. Torsion is something to consider. It reduces rotational forces. There is, however, a reduction sometimes in proprioception. And for the more experienced users, sometimes they can feel like it's too much movement. Maybe they just do it on one side. But if it is adjusted correctly, it can reduce some of the forces that can translate to the socket and help in tight spaces or when pivoting and golfing and things of that nature. So ultimately, give it a try if you have room, if you have space, and the user who's interested, that can be a great option. We're going to talk a little bit about the Kenevo. If you haven't seen the Kenevo, it has 3 different modes in it. A, B, B plus is kind of a part of B, and C. And it's got some new features. It recently just had a facelift, so a dawning feature, an additional mode for biking, an inductive charger, and an app so that the physical therapist can help the user progress through these modes as well. So it can be adapted to the current level of performance where the user is at this time. If maybe they are a long-term C-leg user or X3 user, but they're getting older and they're regressing a little bit. Maybe they don't need the same things that those knees offer, but they need the stumble recovery. So A is locked, B is semi-locked, where it will be locked in stance and free and swing, or this 10-degree flexion block they can get with B+, and C will be a yielding knee. Again, for your design for the K2 population or those with the lower K3 end, but maybe don't need all the bells and whistles of the C-leg. So if we look at kind of why you would pick a Kenevo over a C-leg, we have this progression in rehabilitation or regression potentially. Easier stance release is criteria can help if they're having a hard time releasing. And we have a unique combination of locked stance and open swing, stumble recovery, progressive sitting down and standing up support. So as they go to stand up, this can also be a benefit for the user. So in A, we'll see here Here, maybe they're in their rehab process and they're just, getting used to balancing and moving a little bit, rotating their hip, working on that weight transfer and general therapy. Sometimes sitting down, in this scenario, they don't have to release anything. It's just a posterior tilt, but it can be a little bit tricky to initiate. They may sit down. They can sit down with one leg extended even, and then it will release. And so there are some different options. When they do sit, there's this progressive sitting, so they're able to get control throughout the whole range of sitting, rather than just, initially there's resistance and then it drops out as they progress. So some pretty cool features for both standing up and sitting down. I know our time is coming quickly, so I'm just going to go through some of these a little bit quicker. We are working on a bilateral presentation to put online ultimately, so hopefully we can expand on this. But some of these are just things I wanted to show. Standing up, they do have to reach a 45-degree angle, and then they can lock sequentially in full extension. They might even want to extend one side first and then progress and step all the way up after that, or stand all the way up. If they are having that step through gait, then you may not want to spend too long in A. Try and progress to B, and then ultimately B+. You may also start with one knee in one mode and another in the other. So here on the left, he's in A, he's progressed to B on the right. So that's a pretty cool opportunity for someone to be able to progress fairly quickly and as needed. And there isn't necessarily preference for the stronger side on which, how you may progress, but you can just kind of see where they feel comfortable and start in the bars. We have this mode B+. To get a little bit of stance flexion, 10 degrees, and you can see then they can descend a shallow ramp, and we call this kind of this magical mode for, especially, for a bilateral user, but even for a unilateral user, because they can get this little bit of stance flexion, but it's not going to continue to yield on them if they're not ready for that. And it will help them negotiate those small obstacles like stepping off a curb or shallow ramp. Going to mode C would only be if they're, they're able to handle B+, and they're moving towards, that higher K2, lower K3 level where they are really able to consider yielding downstairs or down a steeper ramp or anything like that. These are just a couple of clips that I wanted to show that we have some training. They are more focused towards the unilateral, but there are some great resources for physical therapy in training stance flexion, descending stairs, steep ramps, and shallow ramps. And these are some great resources that you can, if you have physical therapists that you can work with or are interested in learning more, then they can absolutely reference those. Here is a shot of Xsoft, and there are some great features in Xsoft. You can, again, program with 2 PCs or 2 data stations open. And there is a bilateral option. When you select bilateral, it will give you some presets in here that you can either accept or you can reject depending on what you want. But this is a good starting point, and then you can expand from there. A couple of new features that are in the knees are this deliberate stance. This is in Genium and X3 and was designed with the bilateral user in mind so that it doesn't, to that intuitive stance where they just stand still and bend the knee slightly, then it can activate maybe too quickly or deactivate too quickly. So we created a deliberate option where they have to hold still a little bit longer, and then to deactivate it, they have to extend or take weight off, so that if they're standing on like a boat or an uneven surface, say a bus or something like that, they don't want it to deactivate too quickly. Or they're picking something up off the floor or sitting down, they don't want it to activate too quickly. So these are some different options. There are technician videos embedded in the software that are really great. The C-leg doesn't have this deliberate, but it has a manual option, and that can be utilized for bilaterals as well, similarly. There is the supported option walking down ramps and stairs. So this will just give more support as they go down rather than just your typical kind of constant support that you've programmed. And that stance flexion will increase causing a slower and more controlled descent. So that's just a nice option that can be selected for the bilateral user. There's also supported sitting down, and this is in the Genium and X3, and that can be activated so that the flexion resistance increases during sitting down and the user receives more support. There are, again, these videos, and this is the video that's embedded in the software that you can always reference if you are in XSoft. All right, so looking at bilateral users overall, each user presents with unique situations, goals, and challenges, and it's really imperative to take that time and spend some time on training as well, so that these end users can achieve their desired outcomes. Perhaps even end up on the podium somewhere, run, do all of those exciting things that we see on the internet being what it is today. Maybe they just want to walk, and that's it's completely enough, so just always evaluating that entire picture and perspective. So this is a video of a gentleman, focusing on patient training, PT, energy expenditure, the shorter the limb, the higher you go, focusing with alignment, getting a laser posture, considering locking, one side to practice. This user is wearing a hip, if you haven't noticed yet. I know it says it in the title, but I was going to kind of ask that question, what else is going on with him? So on that left side, he has a helix hip as well. So really a high level, but he's doing awesome. He's working. This is our first day of fitting him. So he's working to gain that strength, and then progressing to slopes and all the different things. Some good cues you can give for walking are, keeping the eyes up, keeping momentum, keeping weight on the prosthesis, through stance, and even, keeping an even step length, all of those different things. So really challenging your users, to walk on various terrain, try walking in the rain, walking on dirt and grass and sand, ice. These are all things that we have to navigate. Crossing crosswalks, walking downstairs. Hopefully there's handrails. There aren't always, so you may have to practice those things. Slopes, navigating barriers, building endurance and stamina, and really learning to trust the knee is ultimately going to give them that advantage. So this is Aaron golfing, and you can see if you look closely at the knees, as he comes to swing through, he lets that back knee bend, or the front knee bends, and then the back knee comes and bends through, and he's able to trust the stance flexion that's inherent in those knees.
Thank you for watching this previously recorded Experts on Demand webinar by Ottobock. Please click the link in the video description to access the quiz and submit for continuing education credit. If you have any questions, please contact the education team at 1-800-328-4058 or via email at us.education@ottobock.com.